Hello everyone, my name is Dave Ghosh and I am currently a 9th grader attending Harmony School of Advancement. For my PBL project, I will be focusing on how compressing a spring will affect the distance that a cart travels. Before I get into the mathematics of my project, I would like to show you both of the demonstrations. Here's the first demonstration. And here is the second demonstration. Now, the first equation that I would like to go over that was involved in this project is for the potential energy of a mass spring system. This equation basically states that in order to find the potential energy that a spring possesses, you must know two different things. You must know K, which is the spring constant of a spring, and X, which is the distance that the spring is compressed. To create an equation from this, you would basically multiply 1/2 by the spring constant, and you would then multiply this by the square of the compressed distance. To summarize this equation, it is basically saying that the potential energy of a spring is equal to 1/2 times K times X squared. Now the second equation that I would like to go over is for the gravitational potential energy. This is different from the potential energy of a spring, mostly because the spring is not considered in this form of energy. This equation requires you to know three different things. You must know m, which is the mass of the object, and g, which is the gravity, and this is generally always rounded to 9.81 meters per second squared if on Earth. And you must also know h, which is the height that the object reached, or the distance that the object traveled. To summarize this equation, it is basically saying that the potential energy of gravity is equal to m times g times h. Here is the data taken during the first demonstration. As you can see, the object started at 0.225 meters on the track and ended up at 0.34 meters. The total distance traveled was 0.115 meters, and it is important to remember that the spring was at the first level. Here is the data taken during the second demonstration. The object started at 0.2 meters on the track and ended at 0.735 meters. The total distance traveled was 0.535 meters, and it is important to remember that the spring was at second level. The second level is twice the distance of the first level. Now we will do the math, but before we do that, however, we must combine the two equations previously discussed. The equation we will use is 1/2 times k times x squared equals m times g times h. For both demonstrations, we will disregard k, g, and m as they are constants. For the first demonstration, we will assume that x in the potential energy of a spring is 1, and it will cause h to equal 1 in the gravitational potential energy equation. This is due to the fact that 1 squared is equal to 1. For the second demonstration, we will assume that x is 2. This would cause h to equal 4 because 2 squared is equal to 4. This creates a ratio of 4 to 1 and can be proven if the total distance is covered during each demonstration. We would divide the total distance is covered during demonstration 2 by demonstration 1, and it would equal roughly 4. Now if we plug in 0.535 meters and divide this by 0.115 meters, it would equal roughly 4.65. This is very close to 4, and the excess may have come from a disturbance during the demonstrations. What this tells us is that doubling the compressed distance increases the distance that the cart travels 4 times. For my social studies connection, I decided to focus on how my project affects society. Some major ways that it affects society is it allows roller coaster rides to be made, and it allows anything that can be launched to actually work. For my ELA component, I created a journal. In this journal, I focus on how the two equations described in this project works. I also focus on how x in the potential energy of a spring is squared. And I also focus on how m times g and k times x gives you force. Anyways, I would like to thank you for watching my video.